Today's lesson is 1.1, Domain and Range, Maxima and Minima. The domain is your possible x values or your inputs of a function. The range are your possible y values or the outputs of a function. Interval notation is a tool for describing groups of numbers in our domain and our range. Intervals are either open or closed, or they could be both. They could be a combination of open and closed. Open intervals, we use parentheses and refer to the intervals that do not include endpoints. They are always used with positive and negative infinity. I did the best I could. Closed intervals use brackets, and they refer to intervals that do include the endpoints. So we will never use these for infinity. Let's go ahead and practice some interval notation with some graphs. So you had a foldable in class, and this is the inside of the foldable. So let's go ahead and start with the graph of x is less than 2. Remember, when you're graphing an inequality, you put a circle at the number. So my circle is going to go at 2, and you have to decide, are you going to leave it opened or are you going to close it in? The way that you tell if it's opened or closed is you look at the symbol. If the symbol has the or equal to underneath it, we're going to go ahead and shade it in. Since this one does not, since this one is simply less than, I'm going to go ahead and leave the circle open. If I am to, then I have to decide where to shade. Where are the numbers less than 2? Well, when the variable x is first, that inequality symbol, the less than right here, is acting like an arrow, and it's telling me to shade to the left. Shade in the direction that the inequality is pointing, which would be this direction. Notice it also kind of looks like this side of the graph. Or you could just pick a number. 0. Is 0 less than 2? Yeah. If I have nothing, that's less than having 2 of something. Or you could pick a number over here. 7. Is 7 less than having 2? No, 7 would be more than having 2. So I'm going to shade in this direction. If I were to write this as an interval in interval notation, what I'm going to do is I'm going to start with the end. I'm going to start with the arrow because I always read it from left to right. So this arrow here on this side is negative infinity, and this arrow on the right side is positive infinity. And this will go for the whole foldable. So I'm going to start with negative infinity. And I know that that gets a parentheses. Then I just put a comma and I put the circle. Okay, so my circle is at 2. My circle is open, so I put another parentheses, and that's it. There's interval notation. Let's practice it again. Same thing, except this time notice that you have the less than or equal to. Now I'm going to go ahead and shade in my circle, and the less than looks just like this one, so I'm going to shade to this side. Or once again, 0 is less than 2, 7 is more than 2, so I'm just picking a number. All right, remember, this is your negative infinity, and this is your positive infinity. So when we go to write interval notation, we start on the left side, negative infinity, comma, we put the number that we see. Remember, we always start on the left and we go to the right side. Infinity, positive or negative, always gets a parentheses, and since the 2 is shaded in, I have to use a bracket this time. That's the only thing. I just have to look at the circle. All right, let's go ahead and look at this one. We're using 2 again. Notice there is no bar underneath. It's just greater than. It is not or equal to, so I'm going to leave it open. This time my inequality is greater than, and it looks like this side. So I'm thinking 6 is greater than 2. Yes. 0 is greater than 2. No. If I had 0 of something, I would have less than if I had 2. That's all. Just a couple of different ways that you can figure it out. Remember, negative infinities here, positive infinities there. Let's start at the left. The first thing I see as I read from the left side is this circle right here. So this time I'm starting with 2. It is open, so I'm going to go ahead and put a parentheses. And then the last thing I see is the positive infinity. Do I have to put the plus? No. And I'm going to always put a parenthesis. All right, the next one looks almost exactly the same, except that it has the bar underneath. So I'm going to go ahead and close in my circle, and it's going in the same direction, so I'm going to shade the same way I did up above. A lot of these you can kind of mimic what you did in the last one. Remember, this is negative infinity, and that is positive infinity. When we start to do our interval notation, we start from the left side. The left side is always the negative infinity. So the first thing I see is 2. It is shaded, so I'm going to put the bracket, comma, and then as I read towards the right, the last thing I see is positive infinity, which always gets a parenthesis. Always, always, always. All right. You might be thinking, I got this. But what if I start using two numbers? So notice that this next one. Graph this or that. Okay, let's start with the first one. I'm going to put a circle at 2, and that circle is going to be open. Okay, I'm going to put a circle at 2, and that circle is going to be open. It is pointing towards the left, so I'm going to go ahead and shade to this inequality, or to this side of my graph, to my negative infinity. Also, 0 is less than 2. All right, now I'm going to go to the next one. I'm going to put my next circle at 6, and I'm going to come back and look. It is just that. It has nothing, there's no line underneath, so I'm going to leave it open, but it is mimicking this arrow, so I'm going to shade in this direction. That's all it is, guys. That's it, which happens to be positive infinity. Now, if I were to write this, I would have to write 2 interval notations because there are 2 graphs on my number line. So I have my first graph, which is right here, and then I have my second graph, which is right here. And in between, I'm going to use this word or to show that there's this gap right here. The word or is going to show that there's a gap in between them. So I'm going to start with negative infinity, which I know always gets a parentheses. And then I'm going to go to 2, since it's open, parentheses. I'm going to write the word or. 6, which is open, so it gets a parentheses. 2 in positive infinity, which I know always gets a parentheses. Let's try it again. So notice right here, it looks very similar. The only difference between this one and the last one is now I see that I have the line underneath. So the only difference I see is that when I circle the 2, I'm also going to go ahead and shade it in. There we go. But it's going to look exactly the same because it's exactly the same. The only difference is that line. So same thing with the 6. You just got to be careful and pay attention and go a little bit slower than you normally would. Don't go super fast because we can do a combination. It doesn't always have to be both of them are closed or both of them are open, and you're going to see that when you get into your assignment. All right, so same thing. I'm going to start with negative infinity on the left side, which I know always gets a parentheses in front of it, comma to the 2. The 2 this time is closed, so I'm going to go ahead and put a bracket. I need to put the word or because I am showing that there's a space in my graph. 6 is my next point on my graph, which is closed, so I'm going to put a bracket, comma, the next number I see is positive infinity, which I know gets a parentheses. Now you might be thinking, well, Miss, what if it goes from point to point? Let's take a look at these last two. Notice in these last two graphing that there is not the word or, and that there's just one, what is called a compound inequality. For these ones, you will always see the less than symbol. Notice you always see the less than symbol, or as in the second one, the less than or equal to symbol. This means I'm going to shade in between the two numbers that are given to me in the compound inequality. So I have the number 2 and I have the number 6. These are going to be my 2 points on my graph, 2 and 6. For this one, they are open. For the last one, they are closed. So let me put them in there because they're basically the same. It's just the open and closed. Okay. Now, you are just simply going to shade in between them. Whenever you have a compound inequality, so whenever your inequality looks like this, it contains two numbers and only the less than or equal to symbol, you always shade in between the 2 points. All right, so what would that look like? Well, remember we have negative infinity on this end and positive infinity on this end, but this time my infinities, they are not shaded. So actually, I'm going to come in here with my eraser and I'm going to get rid of them because guess what? We're not going to use them. We are simply going to use the numbers 2, comma, 6 because it's just going to go from point to point. For this first one, it's parenthesis, parenthesis because they're both open. And for the second one, 2, comma, 6, it's bracket, bracket because they're both closed. Could you have a combination of parenthesis and bracket? Yes. I could come in here and have parentheses bracket or bracket parenthesis. It just depends on where they're open and where they're closed. All right, another way that we can talk about our domain and range is by using something called set builder notation. This uses inequalities and the element symbol when defining a set. So a simple example would be you're going to use the curly brackets, x, and you're going to put a bar. This is the word such that x is greater than 0. Close it off. Okay, I have seen instead of the line, I have seen 2 dots. They come in and they use dot, dot, but the more common one is the line, and this is the one that I'm going to use. All right, this is a symbol that stands for union and is used to connect two groups together. It is associated with the word or. Okay, so instead of writing the word or, I could use this symbol that looks like a U. There's another symbol, the upside down U. This stands for intersection. Let me write that out. And is used for all members in both groups, the first group and the second group. All right, let's go ahead and look at example 2 and identify the domain and range of our following functions. I'm going to go ahead and do the domain and the range in set builder notation, and I'm going to go ahead and show you how you could do it in interval notation as well. Okay, I'm going to show you both. I'm going to grab my highlighter here and the domain. Okay, there we go. The domain, remember, are your x values. So you're simply looking at this x-axis right here, and you're going to pull your graph to it. So the first point I see in my graph is right here. Okay, so I need to know what number this is. So I'm going to pull it up to the x-axis, and this is -1 to -3. So I know I'm going to have to use -3. And then notice it continues upwards like this, and it looks like it's going to kind of get close here to -1. Then it looks like my graph starts again right here, which I would pull to 0. And it comes like this, and it ends right here in this open circle at 1, 2, positive 3. So I have to make sure that I say all of this. I need to start on the left side of my graph and read it to the right side of my graph. So when I'm doing domain, I always go left to right. Here we go. So I'm going to say all my values of x such that, okay, for the first one, I'm going to say negative 3 is less than or equal to x because that is an open point right here at negative 3, or sorry, it's a closed point, sorry, all the way to negative 1. Actually, you know what? I don't think I want to have the line the equal to because it's going to go continuing forever. Or 0 less than or equal to x less than 3. If I were to do this as interval notation, I would simply say negative 3 comma negative 1. I would put a bracket and a parentheses because notice that it's closed and it's continuing forever like our infinity. This is closed because there's nothing there, and then this is open. So I'm going to say, I could say union, or I could write the word or 0 to 3. Very similar for our range. Let me see, let me grab a green real quick to do our range because I have the range in green. There we go. But now I have to read my read it from the bottom to the top. So I must read from the bottom to the top when I do the range. So the bottom would be this one right here, and then the top would be all the way up here. Notice that there's really nothing that's breaking up. Yes, there's this hole here, but I don't need to say that because there's a point over here that has 2. Okay, everything that's here is also here. And so my graph is going to start here at negative 2, and it's just going to continue up to positive infinity. That's what it's going to do. So I'm going to say all the values of y, because we're doing the range, such that y is greater than or equal to negative 2, because that is a closed 2. That is a closed 2. Or if I was doing interval notation, I would say negative 2 with a bracket, comma, positive infinity with a parenthesis. Okay, just depending on which notation you're asked to do. All right, so let's talk a little bit more about the domain and the range. Remember, my domain are my x values. My domain are my x values. And we're just going to go ahead and scan our graph just like we did to include all our values on the graph, moving from left to right, left to right, okay? So if we take a look at the first one and we look at our x-axis, this one right here, I'm just going to go ahead and highlight it on these two. I am moving, if I take this graph and I flatten it down, if I take this graph and I flatten it down, notice it's continuing forever. So if I take it and flatten it, this point here is going to move right up there. And then it would flatten this way. This side would flatten that way. If I take the vertex and move it up, the other side is going to flatten. All this would flatten in that direction. So basically, I'm going to move like so from one end to the other. Remember, negative infinity and positive infinity. That's not going to change. Well, let me put it in this color. Negative infinity, positive infinity. And so basically, I'm going from negative infinity to positive infinity. So I can simply say that it is all real numbers. I can write those words out, all real numbers. Or I could simply say x is an element of negative infinity to positive infinity. All right, let's take a look at the second one here. This one is not continuing because I can see that my circle is only here. Everything would go from this point to this point. So everything up here would squish down here, and everything below, let me let it go away, there we go. Everything below would squish on that line as well. So this looks like -1, and if I count this out, 1, 2, 3, 4, this looks like +5. So I would say it's -1 to +5. It's this inequality, which if I were to write this in interval notation, it would look like this. There's no open circles. And if I were to write it in set builder, it would look like this. I already kind of had set builder done. There we go. All right, let's take a look at number 3. Remember, we are looking at our x in example 3 and 4, and we're just kind of visually pulling that graph down. So notice it looks like the graph starts here and goes in this direction, so I just simply pull it down, and everything else would pull in that direction. This looks like -1, and this would be negative infinity. So I would say x is less than -1. So if I did interval, it would look like that. And if I did set builder, I would just simply add the squiggly bracket, the curly brackets, x such that, and then put my inequality that I wrote up above. I'm bad at the brackets, guys, sorry. Last one, notice that the graph is continuing forever, but it looks like it kind of starts, if I pulled it right here, the top part of my graph would pull down right here, as would the bottom of my graph. So this part of my graph would pull and come right here as well. This is positive infinity, and this is -3. 1, 2, 3. 2, 3, yeah, -3. So I've got x is greater than or equal to -3. I've got, if I did interval notation, it would look like this because there's no open circle. You can visibly see an open circle on a graph, trust me. And if I were to do set builder, I would just simply add my curly brackets to my interval, or sorry, to my inequality that I wrote up above. There we go. Let's go ahead and practice with the range. Let me change this to a green. My range are my y values. My range are my y values. And I'm simply going to scan the graph to include all the values on the graph moving from the bottom to the top. Always from the bottom to the top. So let's go ahead and grab our green, and you're going to see some very similar ones here, but you're going from bottom to top. Bottom to top. This one gets a little bit tricky because you always kind of want to scan it from the top down. Remember, you've got to do the negatives first, and the negatives are underneath the origin. So that's why I need to start at the bottom and scan upwards. If I were scanning this graph, this part right here, which kind of looks like a vertex, would get pulled over to the origin. And then this part of my graph would simply come right here, which would be negative infinity, and then pull it over. This part of my graph would simply come here, which is positive infinity. So if I leave it back on, it would look simply like this, and we would have all real numbers, which is a legitimate, you could actually give that as an answer. Or you could say y is an element of negative infinity to positive infinity. All right, let's take a look at the next one. All right, remember negative infinity is down here at the bottom and positive infinity is up here at the top. So let's look at number 6 here. There is no opening or closing in this graph. This graph is not continuous. So I'm going to find the bottom part of my circle and I'm going to pull it over to the y-axis. And then I'm going to find the top part of my circle and I'm going to pull it over to the y-axis. Everything in my graph is going to go right in between these two numbers. This one at the bottom appears to be -2, and the one at the top appears to be +4 if I count it out. So my graph is going to be in between -2 and +4. Oops, I don't want to use x. Uh-oh. I want to use y because I'm doing range. So I want to make sure that I do not use the letter x because that is the variable that we use for domain. So just be very careful that you do use the variable, the letter y. All right, if I were to write that in interval notation, I would simply write -2, comma 4, and they would both get a bracket because they are closed. If I were to write it in set builder notation, I would just add the notation, the curly bracket y such that, and then I would put the inequality that I already wrote. I like to write the inequality first because then set builder becomes so much easy. I just have to slap on the symbol of it. All right, so just remember we are doing the range for these last two, and so there we go. Notice that we're going from the bottom, remember? So we're starting down here at -infinity, and then the graph is going to go right here. So this graph would go, it would look like this, but it's going to be from here to this number right here, which appears to be 2. So it's y is less than or equal to 2. And if I were to write it in interval notation, -infinity with a parenthesis, because it always gets one, comma 2 with a bracket. And then if I were to do set builder, I'm just going to put on the notation in the front, use my inequality, and the curly bracket at the end. Last one, I'm going to take that vertex. I'm going to take that vertex and I'm going to pull it over here. And then both sides of my graph would get pulled in to right here, which would be +infinity. This looks like the number 1 at my point, so I'm simply going to say y is greater than or equal to 1 because that vertex is not open. Trust me, you'll know that it's open. If I were to use this in interval notation, it would be 1, comma, infinity. The 1 is closed, so a bracket. Infinity is never closed, so a parentheses. And we already have the set builder notation done. We just got to get the symbolage in the front, y, all values of y such that, and then you put y is greater than or equal to 1 and curly bracketed up. All right, the last thing I wanted to talk about is the absolute minima and maxima. Ooh. All right, the absolute minimum and maximum refers to the points of the y values that are either the highest or lowest of the entire function. They are also called the global maxima or minima. The relative maximum and minima refers to the points in the y values that are the highest or the lowest of the local neighborhood or the small region of your maxima and minima. So let's go ahead and identify our absolute and local maxima and minima for our graph below. And then we are done for today. So my absolute maxima, these are the highest and or the lowest. So let me go ahead and I'm going to put the maxima in blue. So I want the very highest point that we have. It looks like it's this point right here, which would be at 4, comma 5. This would be the ordered pair for that point. And then let me go back to my purple for the minima. The lowest point we have would be right here, and this appears to be the point negative or +2, comma -6. So my absolute maxima is the number 5 because it is our y value. Remember, they are our y values. And our absolute minima is at -6. Now we do have some local ones. We do have some local ones. If you go ahead and look at your graph, you do have a local maxima right here. There we go, which is at the point -1, 2. Let me see, are there any more? I guess you could kind of put this one because we don't know what's going on here. So we could kind of say 5, 2. Okay, it's the same thing. See, I wouldn't use these ones on the ends because we kind of don't know what's going on. I kind of get the illusion that the graph is going still like this and the graph is going still like that. I can't tell what's going on. So I'm going to go ahead and get rid of these ones because I'm not so sure. But what I would say is for sure there's a local at 2, and I could also use the global as a local. Okay, so the global's kind of both. So I could go ahead and say at 2 and at 5. And my local minima, the one for sure that I could use is this one right here, which is at -3, -2. So I'm going to go ahead and say -2, but I can also use the one at -6 because it's there on the chart. Good luck on your assignment.